All right, so I don't know about you, but sometimes it's actually easier to explain Bitcoin or blockchain using metaphors, be that at a dinner party or to a journalist looking for a neatly wrapped, kind of easy to articulate topic. That generates a lot of hype, to the point that most people can't actually believe the sheer number of things that blockchains are apparently capable of. I'd say just like in the early days of the internet, it was easier to misattribute something, like an internet-powered bookstore, than actually acknowledge that the existence of the internet simply enabled new business models for selling books. So I'd like to take you a little bit deeper, in the hope that you'll gain enough insight to be able to relate blockchains to your area of business, and to cut through the hype. I've spent a lot of time delivering workshops over the last few years for a non-technical audience, not unlike most of you here today. So I've distilled things down into a few kind of key principles to give you a foundational understanding of the protocols and concepts, rather than the nuts and bolts. Okay, hands up here if you love protocols. Okay, a few, but still not so many. I think what we'd love is what protocols do for us. Right? These are a few of my favorites. They're in the background of many of our daily activities. We don't need to know how they work. We just rely on them to do what they were designed to do, without getting in our way. Much the same way you don't need to understand how SMTP works to send an email. Protocols are utilitarian. If everyone conforms to the rules defined within the protocol, then you'll get the desired outcome. You don't have to care what email client someone uses or what servers will relay your message. It took over a decade for us to get to that point, a little while longer for the standards to be adopted, and then even longer yet for it to be legally recognized. But it happened for email, and we're all the better for it. Similarly, we can thank HTTPS for enabling e-commerce. We simply wouldn't have Amazon or Shopify without them. Protocols don't appear overnight, though, but they do follow a common path, the genesis of which is actually in the institutions that came before them. They have manual protocols in the forms of agreements and processes. They were needed to build bridges across borders to enable global commerce. Then we see platforms start to emerge. They recognize that there's efficiencies in scale and bring everybody together into a similar uniform interface with the rules defined within their platform. From there, it's only a matter of time before protocols can achieve the same efficiencies, but now decentralized, so not everyone's using the same platform or application. And as much as we like to uphold the concept of trust in a brand or an institution, it really does boil down to experience and certainty. Those institutions were immensely valuable, but as soon as people experienced that they could achieve the same outcome with a platform or a protocol, it was actually quite seamless for that trust to transition across. The really interesting thing is when people start using protocols, often without even knowing it. Whether you're dialing in from your office phone or using WhatsApp, you don't care how the call is routed through voice over IP. You just expect a quality connection. Now, the third line here is Bitcoin. It is still controversial, but in the same way that people were relying on banks or PayPal for transferring value, it proves there's a model whereby a protocol can now transfer value. And the outcome is as they would expect. The other person received the value. Here's another lens through to which kind of seeing where the value is captured versus the web or blockchain. These charts are from Union Street Ventures. So in the web paradigm, the protocols are enablers that underpin the applications, like Facebook or Xero. Such applications are likely to be platforms that bring everyone together with a uniform interface. It's then the application that's able to leverage, capture most of the value by leveraging network effects. The blockchain paradigm, however, turns that on its head. Now the protocol is designed to leverage network effects and to capture value by providing a uniform experience. But the interfaces or the applications on top can be as diverse as you'd like. They can serve certain niches or be very bespoke to cater for a real target audience, but everyone's using the same underlying protocol. Okay, so some of the concepts we're dealing with here. Given that blockchains have network effects, it's desirable that they have little or no barrier to entry. They're egalitarian in that anyone conforming to the protocol should be treated equally. While it's still possible to add layers of permissions, the trend is towards fewer layers. You simply don't need 8 or 9 layers between guest and superadmin when you're building a blockchain application. One of the greatest strengths of blockchains is manifested when you're dealing with a population scale or even a machine scale. Where there are so many participants, managing permissions for them all would be increasingly difficult. Now, consensus. So while you don't know every participant, it is still possible to incentivize them to act in the collective interest and form consensus. By achieving an agreement of the current state after every change, all participants benefit from the certainty of the state that relates to them. Some blockchains set the consensus quite high, others make it more variable, but always it's at a level where it makes any malicious update that much harder to achieve. Okay, so if you've got a large number of participants that have formed a consensus about the current state, now you want to make it ridiculously hard for anyone to change the past. Blockchains achieve this with the clever use of cryptographic hashes, the result of which is a chain where altering any record would require you to recompute the hash of all that follow. That's very computationally expensive, and in fact, near on impossible to do at a pace faster than the rest of the network. And finally, we've got decentralization. So if you've nailed the first 3, there really isn't any need for centralization. We've kind of got the benefits. The system can continue to operate in a decentralized manner. In fact, it's such that if you reintroduce centralization, you weaken some of the others. Pull one lever, and the characteristics of the system change. Centralization leads to participation only by trusted third parties and reintroduces permissions. With fewer participants, consensus therefore may be weakened. That's not to say private and permission blockchains don't serve a purpose. In the same way that corporates were initially shy to publish too much information on the internet, so they built an intranet for only internal access. Over time, though, they've opened up to a point where a company's publicly available information now is far greater in quantity and timeliness than their corporate intranet. Okay, now it's time for a definition, and this is a very broad one, but it's still my favorite. I'll break it down for you. So it's a data structure so secure it can be made public. Now, in contrast, databases you'd normally have entirely private. You've got all of your permissions around it, who can control it, you've got it hosted very securely. In this case, it's public by default, so that's quite different. It's one where altering a copy of the data has no effect. So, as Mark mentioned, everyone's holding a copy of the data, but if I alter my copy, that should have no effect. The rest of the network, in fact, I've fallen out of sync. They just ignore me. And finally, records are only appended, never deleted or updated. So you're continuously adding to it. Okay? And that's underpinned by a peer-to-peer protocol. that strictly enforces the validity and the consensus prior to writing. Again, most of our applications today, there's application logic or even database logic that tries to work out the validity, but you can go to write that and get a result back saying the state's changed. That's simply not the case with the blockchain. Okay, so illustrated here is a distributed ledger, which is still the most common form of data structure for blockchains in use today. It's somewhat simplified, but you get the picture that every block includes a number of transactions. The inputs into the transactions have to be an output from a previous transaction in the past. And a new block can only be appended if it, to the chain if it includes the hash of the previous block. That's pretty straightforward, so let's look at the peer-to-peer protocol. Here, Bob wants to send some amount of value to Alice. It doesn't matter what that value is, whether that's a token that represents a movie ticket, or actually a cryptocurrency that has its own ecosystem values within the blockchain sphere. But Bob doesn't send anything to Alice. Instead, he broadcasts a transaction to the network, and in just a few seconds, the nodes have all seen Bob's transaction and independently verify its validity. If any of the validation rules fail, the transaction's thrown out. Again, it's simply ignored. The most important validation is whether the transaction signature matches the address that Bob is trying to spend from. I won't dive into public and private key cryptography here, but I can assure you that there is no way for somebody to forge a matching transaction signature without having access to Bob's private key. Once the validation rules have been met, there are some strict rules for security as well. The majority of the network must form consensus on the longest chain, and there is what is in effect a lottery to ensure that it's entirely random which node on the network will write the next validated block to the ledger. And that's about as technical as we'll go. Now, let's look at how smart contracts relate to blockchains. So, again, a broad definition. As blockchains are good at making sure data is accurately replicated across untrusted entities, smart contracts are good at making sure logic is accurately executed across untrusted entities. I don't particularly like the term smart contract, so they're neither smart nor contracts in a legal sense. But if you're a developer, having logic accurately executed is really important. When we surface that up at a business level, it means that instead of reconciling data before and after a process, blockchains and smart contracts in unison can guarantee the process. Given the same inputs, you'll get the same output without fail. To enable this, the contract code is actually stored in the data structure, and it can be called by transactions that provide inputs into the specific functions. The smart contract will be executed and the outputs recorded along with any change in state. Once again, the protocol's doing the heavy lifting. It's the nodes of the network that execute the contract functions, store the data, update balances, or trigger new transactions. Bob now, say, wants to assert his identity to Alice. So he signs and broadcasts a transaction. This is one that's calling a smart contract and instructing it to share some of his identity attributes with Alice. Alice now has the ability to retrieve and decrypt just those attributes that Bob chose to share. So some of the strengths that surface from all of these protocols and concepts now is we can rely on the fact we have an immutable record with complete auditability. It's a single source of truth that can do away with a lot of reconciliation. We also have a timestamp of data existence. This is one of my favorite properties, in that you can prove that the data existed at a given time based on it having been written to a blockchain. We've seen that we can do consensus at scales that potentially centralized application architectures can't achieve. We also have the proof of digital ownership and the ability to transfer it peer-to-peer. And finally, the autonomous execution of logic. It's not self-executing in the fact that there are still nodes and it does need to be triggered, but the autonomous factor comes into play that the developer who published that code or that logic has no say in whether it's executed or not. If it's there and somebody calls a transaction to that smart contract, it will be executed. But it doesn't come without its risks or weaknesses. The ability to scale is still something that's plaguing blockchains today. There's other risks around business downtime with issues of throughput or latency, mainly across that peer-to-peer network. And it's unsuited to large amounts of data. It's not a database to store every record. You want to keep just the bare minimum of data onto a blockchain. But this is still just the beginning. We already have chains that are structured as graphs, others that don't even have blocks. What we call a blockchain today may be as quaint as the information superhighway in a few years' time. With a rapidly growing community of developers and cryptographers, one thing's for certain. What will be possible in the coming months and years is leaps and bounds ahead of what we can do today. You're going to hear about some incredible projects over the next 2 days, so I trust this presentation has helped you at the beginning of your journey. With that, I'd like to open it up for some questions. Being mindful that time is limited, I'll give a brief answer to most questions, but if you feel that I haven't answered it, feel free to grab me during one of the breaks or attend one of our workshops. So I think we have a microphone on that side. Thank you, Gareth. Who's going to be brave with the first questions?
Do you know any examples of completely trustless peer-to-peer trading, similar to TradeMe but without the middleman?
Yeah, there have been some marketplaces that are trying to be two-sided marketplaces that are trustless. Where it becomes interesting is then the reputation. So you still need that common agreement around a reputation, not unlike how TradeMe has their star ratings for buyers and sellers. But there is one project called OB1, which provides a very similar marketplace type structure. So it's coming. Can we get a microphone in the middle? It's coming.
So blockchains we taught are immutable, but at the end of the day, there's humans involved, so we can keep changing the rules. So our blockchain's really immutable if we have messy humans getting involved.
Yeah, so the data can still be immutable, the logic can be too. Obviously, how we use that data and how we take the outputs of that logic is still open to human interactions. And that is one of the biggest challenges, is we have a lot of existing inertia in our current ways that we do things. And this paradigm shift doesn't necessarily solve everything if we just try to apply existing ways of doing things onto a blockchain. There will always be some element of how humans can best manage that, and I know Pamela's going to touch on that a little bit more, so yeah, if we can get all right.
Just briefly, hard forks and the 51?
Yeah, that's where consensus, if a majority start to actually follow one chain rather than another, kind of breaking that rule sometimes of that longest chain does happen. In fact, there's many forks happen all the time. That's part of the natural execution of the blockchain protocol. But yeah, there are cases where a public blockchain may fork for other reasons, be that software version updates that have got out of sync, has happened a number of times, or a difference in the ethos of the community that are running them. I think that's still part of a good, healthy ecosystem to have that ability to fork.
I'm interested in your comment around participatory and that there's little barrier to entry, and whether you could speak to that a little, because what springs to my mind is that there's huge barrier to entry with regards to capability, interest in this, knowledge about this. So the barrier to entry might not be that if you can do it, you can get in there and do it, but it's like, what are the qualifications? And I think of the social community I'm in, for most people, they wouldn't even know about this. So that's just a huge barrier to entry from a more social perspective.
Yeah, so there's two parts to that. I was mainly talking about barriers in terms of being allowed to do something, right? Or needing to sign up, or having some onboarding process. Those are the barriers that we're mostly focused on removing in a blockchain. Then there's that, obviously, technology, and that's why I was starting my talk around the protocols, and it's really good when people don't know they're using them, and we're not there yet with blockchains yet. Although there are some other parallels, things like WeChat, where a large portion of the Chinese population, within the space of 2 years, went from not understanding peer-to-peer transfer of value or QR codes to just treating it as a part of normal daily life. So while it may still seem jarring, I think given it the right application and the right kind of use around it, it will be something that people can relate to and start to use, even if they don't know how it works.
So my question's around private versus public blockchain. The public blockchain, the data is protected. You can't read the data unless you've got the private key. Is that correct?
It depends whether you're encrypting the data as well. So we talk about cryptography, and it's mostly used in a blockchain for just those hashes, those fingerprints of the data at a given time. However, if you put data on there, that is completely transparent. So then you need another layer, which would be to encrypt the data first.
So you can encrypt within the encryption, as it were.
Yeah,
okay.
And then also to solve some of the problems around the amount of data that you want to store, you might not store the raw data itself. You can, again, put a hash of the data. And then if you have the data stored on another protocol or in a database somewhere, you can still surface and prove that that hasn't been altered. So you still get the properties of immutability. Yep.
So now we've got miners solving proof of work or validating transactions.
Yep.
So stating Bitcoin, there's a finite number of coins or finite number of rewards you get for mining. So will mining stop? And what happens if mining stops due to lack of rewards?
Yeah, there's still two layers of rewards. There is the transaction fee, and we expect that that will increase over time. Already the Bitcoin transaction fee is about 50 cents now, from being just a fraction of a cent only 2 years ago. And yeah, there is still a vested interest in keeping that system going. We might not see the same amount of this kind of arms race of the hardware investment that's gone in to secure it and to make it more powerful than all the supercomputers combined. But that's not necessarily a bad thing either. We also have other blockchains that don't use proof of work, therefore a lot less electricity consumption. And we have the ability to peg between them. So you might still end up with one core, high-value kind of blockchain, not unlike Bitcoin, which has then higher costs of using to keep rewarding the miners to operate it. But then you can get lower cost kind of side chains or other blockchains for more higher volumes of transactions and those things.
Thanks, Paul.
Hello.
Hi.
If I were to attempt to subvert a blockchain, how would I go about doing it? Would I put out a bogus security update if it's VM or something like that, affect the smart contracts? How would I go about subverting a blockchain?
Yeah, that's really difficult. So there is still instances where, yeah, that's open source software. People may just install an update without actually verifying it. However, I'd say the majority of the miners or people running a full node on the network do check and do make sure that nothing malicious has been updated in the software since the previous version they were running. So yeah, that is still a attack vector, like on any network, not unlike somebody trying to break into a data center and put an updated version of an operating system or a library into there where you're executing your applications. But it is much harder to do just with the decentralized nature of those people running the software. Okay. I think that's about it for question time, so thank you very much.